Welcome back. For whom among us is this your first time attending an Asimov? You know, been doing this for 25 years. Like, where have you been? First, some housekeeping. Sonny Williams and Butch Wilmore have arrived safely on Earth's surface. The two stranded astronauts, stranded in a 2,000 square foot apartment with a half dozen other people, food and water, were stranded. Professional astronauts who've been up there hundreds of days each were stranded and just rescued today. Just thought I'd. Couple of other notes. This is the 26th annual Isaac Asimov panel debate. This was formed on a gift from Isaac Asimov's estate, at the time overseen by his widow, Janet Jepson Asimov. Isaac Asimov was a friend of this institution, more specifically of his 600 books, plus books that he wrote, rumored to have at least one book in every branch of the Dewey Decimal System. Yeah, that's pretty good. If you're a prolific author, you can say that. He did most of his research for his science fiction and his nonfiction contributions to literature in our research library. And so we feel sort of genetically connected to him. And this panel debate is in his honor, in living memory of his contributions to this civilization. And again, I am Neil deGrasse Tyson. I'm the Frederick P. Rose Director of the Hayden Planetarium. And I also want to, fine, thank you. You already applauded, so I don't need a double on that. And I just want to recognize that this evening we have Sean Decatur, president of this institution, with us in the audience. Sean, thanks for coming. We spent months debating, discussing what the topic each year should be, and we want it to be scientifically interesting, a little bit challenging perhaps, also culturally relevant. And this year's topic just ticks all of those boxes, perhaps more so than any other subject we have presented, and that is the topic of geoengineering. And you shake just saying the word. Even if you don't know what it means, it's like, oh, that means something important, which in fact it does. So we are going to, we'll have a panel of 6. Each member of the panel will briefly introduce themselves, and I will come at them with this series of questions that we will openly discuss. None of us are presenting to you. We are having a conversation among ourselves, and you are eavesdropping on this conversation. Scientists arguing with each other. And from our polls and from our understanding of what people value, that is very high on the list, because it's too easy and too often where a scientist comes in and gives you a polished presentation. I want you to see what goes on in the coffee lounges of conferences. And because science, on the frontier, on the bleeding edge, we don't always agree. And it can be illuminating to learn the ways in which we disagree and how we resolve them, if we resolve them. So, allow me now to just bring out all 6 panelists, and they'll then introduce themselves briefly before we get into the conversation. Come on out, all 6 of you. Here we go. Kevin, tell us give me 3 sentences, who you are and why you're here.
Hi, everyone. I am Kevin Surprise. I'm a professor of environmental studies at Mount Holyoke College. I've been studying the economic and geopolitical questions surrounding solar geoengineering for about a decade now, trying to trace and understand how these technologies are being integrated into climate policy and why that might be a bad idea.
Or why it might be a good idea.
Why it might be a good idea, but probably not.
Don't prejudge. Just it can be a good idea. Holly, please.
So, hi, I'm Holly Jean Buck. I'm a sociologist. I work at SUNY Buffalo. And I go out and talk to people. I do interviews, focus groups, surveys, not just because I'm curious what they think about these emerging technologies, although I am, but because I want to learn about how the public can have more influence in shaping how these conversations go and how these technologies get deployed or not.
And we never know if we have any influence at all, the way things go, typically. Yeah. Beth.
My name is Beth Chalecki. I'm an associate professor, of international relations at the University of Nebraska, Omaha. And I've been interested in security my entire academic career. And it wasn't until a trip I took to the former Soviet Central Asian states when I realized the environmental damage that comes along with producing nuclear weapons. And that's when I realized how important the field of environmental security was. If we don't secure the environment, we don't have anything. So geoengineering just seems to be the wickedest of wicked problems, and I'm interested in learning more about it.
You already used the word wicked in your description of it.
Twice.
Yes, okay. Tell us about yourself.
Hi, I'm Dustin Mulvaney. I'm a professor of environmental studies at San Jose State University, and I study decarbonization strategies and the impacts of emerging technologies with an emphasis on solar power and lithium-ion batteries. So I think about probably alternative strategies to geoengineering in solving the climate crisis.
You say lithium batteries, but also any minerals at all that would have value to the emerging technologies.
And any critical minerals, yep.
Critical minerals, sure. All right, Harold, what you got for us?
Hi, I'm Howard Herzog. I'm from MIT. I'm a chemical engineer by training, and my focus has been on energy systems for the past 35 years, and basically low carbon energy systems. I've done things like geothermal energy, but the bulk of my research moved toward carbon capture and storage, which is capturing CO2 from point sources like power plants before it gets into the atmosphere, and then it's got me into looking at removing CO2 from the atmosphere once it's already up there. I have a book coming out in August called Carbon Removal, and that's on this topic.
All right. And Daniele, talk to us.
Yeah, hi everyone. I'm Daniele Visioni. I'm a professor of climate science at Cornell University in the Department of Earth and Atmospheric Sciences. I'm a climate scientist, a climate modeler, and for all of my research, I've tried to push forward our understanding of the climatic impacts of solar geoengineering. And I take the probably naive view that having good, robust, scientifically backed information about something can help us make better decisions about that thing. Still think that's true. So here I am.
So you're the wicked one.
I am the wicked one. I've been called like that many times. Yeah.
And you're Italian.
And I'm Italian,
Yes,
if
yes,
you hadn't
well.
heard from the way Neil pronounced my name. Yeah.
Daniele Visione.
Love it.
Yeah. So let me start with you. So you are a fan of changing the reflectivity of Earth using aerosols in the upper atmosphere to reflect back sunlight so that there's less energy on Earth to heat us up as a solution to our climate change problems. Could you just describe what that involves?
I'll have to take a step back and say that I'm neither a fan, nor do I think it's a solution, but I think it could be an interesting part of a much broader solution. And yes, fundamentally, I've been studying the behavior of stratospheric aerosols, so tiny suspended particles in air. We've known for a long time that these particles are everywhere around us, and in particular that if any kind of source, whether human or natural, releases sulfur dioxide into the atmosphere, this sulfur dioxide oxidizes, produces tiny aerosol particles, and that these particles, they grow at exactly the size necessary to sort of reflect back part of the solar radiation.
So they have their size equals the wavelength of the visible light coming from the sun.
Due to an interesting interplay of chemistry and microphysics and gravity and so on, if you let these particles grow, they grow exactly to sort of the submicron, alpha micron, 1 micron scale. That is exactly the wavelength of light, which makes
A micron is a millionth of a meter.
a millionth of a meter, and it's exactly the wavelength of light, which makes them perfect or near perfect scatterer of sunlight.
So you call them aerosols. When we think of aerosols on Earth, we think of spray cans and things. Are we all thinking of the same definition?
No, and that has been, curiously, a huge debate when it came to the COVID era about what is an aerosol and what isn't. Normally, climate scientists think of aerosols as really just submicron particles, whether solid or liquid, that are suspended in air. But those are not particles that are really visible in the same way that larger droplets, what we call droplets, are. And the thing about aerosols is that their size is small enough that aerodynamically they float in air for much longer times than larger particles that we can actually see.
Okay, so you said they float for longer, which means they do ultimately fall out.
Yeah.
So you have to send up another batch.
Yeah, and the thing is, the way in which most aerosols get removed from the atmosphere is normally through rain out, wash out, as in clouds raining on top of them and bringing these particles down to the ground. Fundamentally, in the stratosphere, we have observed out of things like volcanic eruptions that once these particles get released all the way to the stratosphere, they stay for much, much longer than they would close to the surface.
Remind us, the stratosphere is above all of the weather.
Yeah, we live close to the surface, but in what we call the troposphere, where there's turbulence and there's clouds and there's humidity. And on top of that, there's a much quieter part of the atmosphere, what we call the stratosphere, because it's very stratified. And things that end up there, which are not that many, they end up staying there for quite a long time, but not forever.
Good to know. Let me just remind people, while they are each professors at their respective institutions, they are speaking out of their own expertise and not for the institution itself. Just want to make that clear. So, Howard, I'm delighted to know that someone such as you exists who's thinking about removing the carbon dioxide from the atmosphere. That sounds like the obvious first thing to do, or the second thing to do, whereas this sounds a little more like science fiction here, that in any good science fiction story goes bad halfway through the storytelling, we know. So just can you give us the top 3 best ways to take carbon dioxide out of the air?
So there's a whole array of ways to do it, and basically you either can do it biologically or chemically. On the biological side, I think people maybe are familiar with planting trees. We've heard that, afforestation, reforestation.
So planting a tree, the tree absorbs the carbon dioxide from the air, and it's in its own physical body.
Right.
Okay.
And of course, there's the permanence issue, how long will it stay there? As we see, there's forest fires and things like that. So that's an issue with it. You can also harvest the trees and convert them into something, so you can burn the trees at a power plant and capture the CO2 at the power plant and pump it into the ground. And so that, once again, the trees take it out of the atmosphere and we capture the CO2 and put it in the ground, so we're pulling it out of the atmosphere to the ground.
So trees are CO2 concentration machines, if you will. Because otherwise you're grabbing, what is the CO2 fraction of our atmosphere? It's very low, half of 1% or something?
420 ppm, 0.04%, 0.042%.
Oh, I was off by a factor of 10. Yeah, good. Okay, but a tree gathers it all, and now you do what you just described,
right,
and you've got it at the source.
And if you do it chemically, it takes a lot of energy. The nice thing about biologically, the energy comes from the sun through photosynthesis, so you don't have to add any energy to that. If you do, one of the big methods doing it chemically is something called direct air capture, and think of a air purifier in your house, but these are on a much bigger scale, and you blow air through these systems and they take out the CO2. Once again, you capture it and you can put it underground.
Ideally, you would do that near the highest concentration CO2 producing places.
No, well, no, you do this out of the air.
Just out in open air.
Yeah, and because it's only 420 ppm in the air, it's a lot more difficult than doing it, say, at a power plant where it may be 10% in the
Right, exactly. That's all I was saying. Right, okay.
yeah.
So ppm parts per million.
parts per million.
Yeah, yeah.
So, yeah.
All right, so tell me about the plankton solution, because that was new to me.
The
The
what's the-
plankton solution to this. The plankton are absorbing carbon dioxide, the phytoplankton?
Oh, in the ocean?
Yeah,
Okay, well, I mean, in the ocean is a big sink of carbon right now. In fact, about half the CO2 we put in the atmosphere ends up in the ocean. And over time, 80% of the CO2 we put out today will end up in the ocean. There's two ways, well, the way that it works is the surface layer of the ocean is pretty much in equilibrium with the atmosphere on a time scale of, say, a few months. So as the CO2 goes up in the atmosphere, it goes up in the surface ocean. However, to get it from the surface ocean to the deep ocean, where the bulk of the storage is, takes centuries. So that's a slow process, and that's a lot of that's done what's called a salinity pump, where you have sinking currents in like.
so I thought there's no life form that does it at the surface and sinks?
Yeah. Well, yeah, and then there's something called a biological pump.
Right,
which
that's
you're
all.
talking about, and there's where you get the phytoplankton. They die and they sink, but most of the phytoplankton that dies and sink do not get to the deep ocean, but it gets what they call remineralized, or it gets basically turned back into CO2. So both of those mechanisms are a way to get into the deep ocean that you have there. But it's really the inorganic cycle in the ocean, and when it's in the ocean, it's not in the form of CO2, but it's in the form of bicarbonate ions. About 85% of the carbon in the ocean is formed of bicarbonate ions, and because the CO2 has this chemistry in the ocean, it's like 30 times more soluble than, say, oxygen would be in the ocean, and that's why it's such a good sink of carbon dioxide.
It's a sink, but if we reduce the CO2 in the air, that pulls it out of the ocean. So the ocean is is like a spigot.
Yeah, well, because of the time thing. So if we stop today all CO2 emissions into the atmosphere, magically do that, the ocean will still absorb CO2 from the atmosphere for a few centuries. Of course, the rate that it absorbs will continually to go down until the whole ocean hits equilibrium with the atmosphere. Then after that, and you start pulling it down from the atmosphere, then you can see degassing.
I didn't know there was
from
that
the
time
ocean.
delay, because the whole ocean would need to go into equilibrium for that to happen. Dustin, so you have a PhD in chemical engineering?
No, environmental studies. I have BS in chemical engineering.
BS in chemical engineering and a PhD in environmental studies, yes. So with that profile, what do you see are the paths forward for society for our growing energy needs?
Well, in
Because the energy needs are not going to slow down.
yeah,
Everything we read about what we need to sustain AI,
Yep.
What else? Other computing
centers,
farms,
all that
Bitcoin mining, that sort of thing. Yes.
yeah, Bitcoin scams. Yeah, so when I first started teaching my energy and the environment class 15 years ago, wind energy was 1% of U.S. supply, and solar was 0.1%, and coal was 42%. And last year, solar and wind combined to match coal power. By 2032, solar power alone is going to top all coal-fired generation in the world.
Solar power alone.
Alone.
Is that because
That's 7 years
because it's
from-
gotten cheaper to invoke?
Gotten a lot cheaper. So I think the fastest path to decarbonization is to deploy renewable energy, and we need to do it in a targeted way, and it has to begin with trying to retire all of the fossil fuel power plants in the world.
Yeah, but you can't do that.
You're kind of popular, aren't you?
You've just gotten 3 applause.
It's the most popular technology in the world, Neil.
Okay, but yeah, you can only say that because solar energy is getting cheaper. So obviously people are going to go for the cheap solution. They don't otherwise care what comes out of their wall faucet, if it was made by coal or by wind or solar panels. So this is not by changing people's hearts, is it? It's by changing the economic landscape on which a person makes a decision.
It's changing the economic landscape, but it's also considering many of the other impacts. So the geoengineering conversation is obviously a conversation about tackling climate change, but we have air pollution that kills millions of people. We have fly ash ponds outside of coal-fired power plants that often break open and flood communities and toxic poisons. So we have a lot of environmental impacts from our conventional energy technologies that aren't part of the calculus of making energy cheap. So we have to both deploy more renewable energy, but we also start to adding costs to the conventional sources.
Thank you. Beth, you have a PhD in international relations.
Yes.
And you also coined the term, I have here, environmental terrorism. Could you comment on what you meant by that in your published works?
What I meant by environmental terrorism, I've been looking at climate change and security for a few years while I worked on a think tank in the West Coast. And it occurred to me that if terrorists really wanted to do damage to a country, if they really wanted to affect its government, its population, strike terror into people, and then get them to change some policy or some operation, that the way to do it isn't to fly planes into buildings. Not a lasting change. Okay, I'm trying to put my terrorist hat on here, like I have a terrorist hat. And the way to do it would be to attack their natural resources. So you would set forest fires, you would blow up infrastructure, you might ruin their ecosystem if you had that ability. And this is what I meant by environmental terrorism. The environment could be a target of terror or it could be a tool of terror.
Maybe the terrorists are not that educated to know how to do that.
Well, if they'd read my article.
So whatever solutions may come out of this conversation, it becomes a security risk, basically,
It might
as a
become
target.
a security risk. It depends on what method of geoengineering is being used. Geoengineering, as we all know on this panel here, this is a huge umbrella term that covers lots of different kinds of technologies, some of which are not problematic, particularly from a security point of view. Others very well might be. And so if I'm an enterprising terrorist, boy, I'm just digging a hole here. If I'm an enterprising terrorist, I'm going to look very carefully at what kind of technologies are being deployed and how I could affect that to my own advantage.
Watch out, you could get deported after that.
Chicago.
Holly Jean Buck, your PhD is in sociology. It's one of my favorite fields, a field of my father's, I will say. He was active in the civil rights movement. So I have a sensitivity to how people think and feel about the world, about science, about technology, and as do you. So I'm delighted to have you on the panel. And what do you see in this conversation, what do you see might be social barriers to its enactment? Do people often vote for something that they don't understand if we're just told it'll solve your problem? How do people... What? Take us through the interface between human conduct and solutions, societal solutions that are presented to them.
So that's a huge question, but I'll say two things. One is that we have a bunch of technologies that we started to adopt without really thinking about it, and I would put the smartphone and social media and things like that in that category where we just got used to them, everybody thought they were great at first, and now we're asking questions. Same thing with some of the chemicals, PFAS, you've heard of. These sorts of things have unintended consequences.
But those are the forever chemicals?
Yeah.
Yes.
Yeah, and so people are looking at, different examples thinking, well, that didn't go so great for us. Maybe we need to take a different approach to how we think about adopting and making decisions on new technologies.
Yeah, but nobody at the dawn of the smartphone is thinking one day it'll create personal image problems, or that it would be the greatest source of misinformation ever conceived. No, how could we have seen that?
That's the interesting thing about this topic, and part of why I work on it is because a lot of the people who are the scientists are actually asking these questions at the outset. And hopefully they can continue to have the primary place in this conversation.
But the examples you give from the past are where we did not see the outcome coming.
Exactly.
So that doesn't bode well for the future. Okay, I'm just saying. Kevin, you have a PhD in geography. Okay, what's the capital of?
Not geography.
Not geographers don't learn that. That's not a thing. What,
It is technically geography. Go
okay,
ahead.
capital of Upper Volta.
Oh, no, no, no.
Yeah.
Upper Volta doesn't exist anymore.
Oh, it doesn't exist anymore?
You'd know that.
At the time I learned what the capital was of Upper Volta, it was the Wagudagu, and I thought that was really cool. Out-of-date information now. With a PhD in geography, it might uniquely qualify you to comment on the global consequences of this conversation and how it can affect different places in the world, their climate. Will everyone improve it the same way? Are there differences from one place to another? And do we need to be thinking about this?
Yes, we do need to be thinking about it. And I don't know if a PhD in geography makes me uniquely actually, it does. I don't know what other people are even doing on this panel. I'm uniquely qualified to talk about this. Yeah, so geography, it's not state capitals and all of that. It's broad discipline that if it has any unifying center, it's a focus on human-environment relations and how they emerge and are interlinked across scales in various ways. And within that broad field, I am, my subfield is political geography, and more specifically, political economy of the environment, which means I think about the ways that capitalism as our dominant economic mode both drives environmental problems and constrains our ability to respond to them. And in terms of geoengineering, I think solar geoengineering specifically, there are a lot of really important questions as to who's going to be, what are the environmental effects of this? Who's going to be impacted? Is it going to be uneven and unequal? It will. We have to compare that with climate change. But my primary concern...
What you mean is, whatever the drawbacks are of solar geoengineering, there'll be pluses and minuses. There are already sort of pluses and minuses to other things going on here now.
Certainly.
So it's an exercise in relative risk factors.
Absolutely.
Is that a fair characterization?
Yeah, we wouldn't be having this conversation about solar geoengineering if climate change didn't present massive risks that we have to deal with as immediately as possible. But that's actually my central problem with a lot of these technologies is that I worry that we live in an era of where corporations and billionaires have massive power, where geopolitical contestation is on the rise, where countries are rearming and authoritarianism and fascism is eroding the old order. And so a technology that could potentially give the fossil fuel industry, the wealthy and powerful more broadly, the ability to deal with the climate crisis without cutting emissions, right, or at least slowing down efforts to cut emissions, is deeply troubling. And I really can't see, I find it impossible in those conditions that I just laid out to see any other way for this technology to unfold other than being a tool of the powerful to maintain their wealth.
Howard, if you figure out how to remove CO2, then what's to stop, either politically, culturally, economically, what's to stop oil companies from continuing to drill, baby, drill? If you have a way to remove the CO2, there is no harm, is there, in burning more fossil fuels? Like, what do you care at that point?
So it's really a magnitude of scale. So yes, we can remove some CO2, and I think if we're really going to hit net zero, it's going to be essential that we remove CO2 because we're never going to be able to stop all of our greenhouse gas emissions. Some things are going to be very expensive, like flying airplanes without jet fuel. It may be cheaper to offset it by removing CO2 from the atmosphere. We have a lot of greenhouse gases.
Just so we're on the same page here, if the rule is net zero, it means you can produce CO2, but somewhere else in the equation of your business model, you have to be removing it.
Right.
Correct?
So net zero means you're removing as much as you're emitting. But there's also greenhouse gas emissions from agriculture, whether it's belching cows, methane, or N2O coming off of from fertilizer use. So you are going to need some of it, but it's the scale. I mean, to use no matter what, I think when we hit net zero, you're going to be using a lot less fossil fuels than you use today. And some people think, if you look at the models, they project, well, we may need 10 to 20 billion tons of CO2 removed a year. So the world puts out about 40 billion tons and maybe another 10 billion tons of equivalent in greenhouse gases. So 10 to 20 billion tons is a lot. And from my analysis is we're going to fall short of that. So you're not going to be able to burn fossil fuels willy-nilly. We're going to need to reduce our fossil fuels drastically and use carbon removal to get us that last 10, 20, maybe 30% to net zero.
Dustin, what spooks you most about all this? But you got 3 applause the last time. Let's see if we can get you a 4th one.
Well, I feel like even the climate problem has reduced the challenge to just being a one-dimensional problem about carbon dioxide, and I worry about ecological consequences. I worry about communities not being able to speak for themselves or speak for places that they think are important.
Or to have a place at the table.
Yeah.
When decisions are getting made.
Yeah, I think that we have to have, if there are efforts to do geoengineering, but I think even broadly, if you're talking about wind power or solar power, having public participation, having tribal consultation here in the U.S. context, these are all really crucial.
Native peoples. Yes.
Yeah.
Daniele.
Can I just?
Yeah, butt in.
Yeah.
This is what we're here for.
I think there's a misconception out there that renewables can do it by themselves, and there's no one technology. So electricity, maybe 30% of our energy use today, and really wind and solar, getting above 60%, maybe 70% if you're lucky, is about the best you can do because they're intermittent. And you really need, for our society today, you need 24/7. You need high reliability. You need 99.999%.
But Howard, you're avoiding the obvious other N word in the room, nuclear.
Yes.
Okay? One of the 2 N words you're not supposed to use. Holly, what do you feel about nuclear? How do people feel about nuclear? It's portable, not portable, but you can make local plants and it doesn't depend on the sun and you make as much as you want at any given moment. You've thought about nuclear.
Yeah, I thought about nuclear because I wrote a book about ending fossil fuels and I had to take a deep dive into how the energy system works, Dustin's area of expertise. And I came to the conclusion that we need nuclear, geothermal, other clean firm. People are concerned about nuclear because of a sense of dread, because it was associated with nuclear weapons back in the day, but we've really seen sentiment
and today.
On this. Well, let's not go there yet.
Back in the day and today,
yeah.
Nuclear weapons.
Sentiment has shifted a bit, and we need a lot more investment in it.
Do you think the economics will make people more comfortable with nuclear options here? The economics, that is, if everything else is really expensive and nuclear power plants. France has been using nuclear power for decades.
Yeah, no, the Department of Energy did a report called the Nuclear Liftoff, and they found that the system costs, if you add in nuclear with renewable and solar, it could lower the cost 37%. So it could be help the affordability of the whole transition.
So, Daniele, the confidence you have in your models, because it spooks so many of us, Dustin especially perhaps, but also Beth is just concerned how this will play out internationally. Does your confidence in your models come from just because you just make badass models, or do you have some other reference frame to give you confidence?
I mean, I do make badass models. But the whole job of a climate scientist is trying to understand the system and finding natural example to allow us to understand whether we're actually understanding the system as well as we think. For instance, when it comes to climate change, Arrhenius back in the 19th century had already guessed that increasing CO2 concentration would warm the planet. That is really not nuclear science.
So that was like early climate science modeling. And tell me the name of the scientist again?
Arrhenius,
Arrhenius.
one of the first, most famous chemists
Chemist.
in the world. He already guessed that, CO2 traps long-wave energy. The planet, like every
Well,
other
that would be infrared.
radiation. And the more CO2 you add, the more you add to the greenhouse effect. But in a way, we did not have an actual physical proof of that until we started seeing temperatures warm, until we sent satellites up in the atmosphere, and we could measure energy in versus energy out and actually see this gap growing. Now we can see this gap growing, and so in that way, we know that climate change is happening.
What about volcanoes?
Right, and the same way, we've known for a long while, there were hypotheses of the fact that large volcanic eruptions could cool the climate. Benjamin Franklin actually hypothesized that was something that happened after the Tambora eruption in 1815. And for a long time,
in Indonesia.
Yes,
Yeah. Mhm.
yes. And during the 20th century, there were multiple of these large volcanic eruptions, the last one being Mount Pinatubo erupting in 1991. After this eruption, Jay Manson, one of the greatest climate scientists of our time, said in one of the first papers after Pinatubo, this is going to be the acid test for climate models. If we predict, as we are, as our...
Jim Henson.
Yes?
Yes, of NASA.
Yes,
Goddard.
indeed.
Who's right
Yes.
up the street here. Yes.
One of the greatest climate scientists in the world. And right after Pinatubo, he said, our climate models, once we add these aerosols that are coming from Pinatubo to our climate models project that the planet will cool by even up to half a degree. And so
By how
if
much?
we get half a degree Celsius.
Oh, half a degree. Uh-huh.
Yes. And so if our models turn out to be right, that's going to be the acid test, that's how we called it, of our understanding of climate. And indeed, we did observe a strong cooling after the Pinatubo eruption. And what this Pinatubo volcano did, it threw in the atmosphere, in the stratosphere, millions of tons of sulfur dioxide, roughly 20 million tons of sulfur dioxide. And this sulfur dioxide produced the aerosols, cooled the planet, and we saw that. And after 2 years, the aerosols were gone, removed from the stratosphere.
These are the aerosols you want to put in the atmosphere to do the solar geoengineering.
These are the aerosols that are being studied in our climate models to figure out whether they will cool the planet. Yes, but not the ones I want to put.
You still haven't gotten an applause from the audience.
I'm sorry. It's cheating.
But, Beth, it's not just his models. He has data from nature doing exactly what it is he intends to do, and they see the consequences, they see the fallout. So why doesn't that give you some, is the word security, some comfort that the ideas are in the right direction?
Because nobody can blame nature. Nobody made that volcano go off. It went off on its own. But if nations actually try to start putting this stuff up into the atmosphere on purpose, now you have some states who are going to benefit by this, other states who may not benefit by this. It's going to take an extraordinarily long period of time, decades maybe, to see the effects that we want. And this opens up the political arena for a lot of misunderstandings and security calculations, I'll put it that way.
Could this be because the whole world isn't educated to the same level to have a common conversation about the need or the cause or the effects of this?
No, I think they can have a common conversation about this, but what we're not recognizing in this attempt to adapt a planet-changing technology, that's what it is. If it's not planet-changing, it's not doing its job.
Right.
So it better be changing the planet, or it's pointless. It's just random pollution. But this is a planet-changing technology, and we need to think about how states would react to this with their own interests in mind. Climate change is going to break international relations as we know it, because we have the whole system based on the idea of sovereignty. Security comes from sovereignty, meaning you control your own territory, your borders are inviolable.
But you don't control your own air.
No, you don't. But we don't recognize this yet. States don't recognize this. And as a result, they are making decisions to participate in treaties or not participate in treaties, to withdraw from treaties, to ignore them, to do side deals for oil.
We had a good treaty in the 80s or 90s. There was the Montreal Protocol.
1985, yes.
Yeah, 89?
87. Sorry, my bad.
87.
87, where everyone got together and agreed that we want to protect the ozone of the atmosphere. And if memory serves, that had more signatories, more countries signing it than any other treaty ever. So that's an existence proof, as we'll say in mathematics,
Right.
that it's possible for the whole world to get together with a common goal.
It's possible. At this point in time, it's unlikely. And let me make a distinction between what we were trying to address with the Montreal Protocol and any kind of climate treaty. There were
You're allowed to be a little optimistic at some point.
I'm trying to get there. I'm trying to get there.
At some point, we can.
I'm trying to get there.
Okay.
This was a materially different regime, right? There were only a few chemicals that were being looked at, CFCs and others. There were only a few companies and a few countries that produced this. We only used them in a few applications, and there were already a substitute lined up. So now...
You're saying CFCs, the chlorofluorocarbons.
Right. CFCs and the HFCs, the hydrofluorocarbons, which turned out to be a greenhouse gas, oops, that we used in substitutes were already ready. So now we look at climate treaty and we'll say, we'll just use the same structure. But good God, this problem is exponentially bigger now. Every country in the world is either producing or using, or both, fossil fuels. It underpins the entire global economy. And now we have to try to get everybody on board and basically say to them, you need to reduce your carbon emissions irrespective of the state of development you're in. States are not going to sign on to this.
There's a scientist in my department, a visiting scientist from Sweden. And I said we're about to do this panel. And she said, you know, if the world gets a little warmer, that's okay with the Swedes.
And it's okay with the Russians.
Right? So it's only bad for the people for whom it's bad. And if you're going to say, let's fix us, and then you make it worse for somebody else,
that sounds inhumane, but that might be a rational security calculation for a particular state, which would incentivize them to develop this kind of technology further.
Kevin, where are you on this?
Well, a lot of places. I think what might add...
Pick one of those places
Sure.
and share it, yeah.
Dig your way out of that.
As Beth was talking, what always helps me think about this is thinking about not in the abstract, but going off of the models that we have. And Dan might be able to correct me on this or fill in some of any of my errors. But some of the modeling that's been done in terms of what it would require to literally change the planet, right, is in a moderate scenario of like 15 years, which, given the fact that we're not cutting emissions fast enough, we're going to have to do something like solar geoengineering for much longer than that, right? There's work that's been done that suggests that we're going to have continually flying aircraft, which don't exist. We don't have the aircraft that can go high enough with a big enough payload, from multiple different bases placed across the planet. 61,000 flights a year for many decades, right? So we're going to have a huge intervention of aircraft continually spraying sulfur dioxide or whatever chemical compound that they come up with that works.
You're saying that's what it would take?
Yeah, and that's
Danielle,
in a moderate...
the aircraft are not flying in the stratosphere, so how is this deposit of aerosols getting to the stratosphere where you need them?
Say again?
What?
I could not hear from you.
Sorry.
Here.
So he's saying to deploy these aerosols would require this network of airplanes flying high, releasing these aerosols continually to achieve the ends sought. Yeah. But if airplanes fly in the troposphere and you need the aerosols in the stratosphere.
Yes.
Tell us stratosphere in Italian.
Haha, stratosfera.
Yeah, love it, love it.
You got me there.
It's a stratosfero. How do you get this up into the stratosphere?
Yeah, I think Kevin does make a good point. Fundamentally, and this in a way one could say it's a positive thing, we are not currently doing solar geoengineering because we can't. Because nobody has been, in a way, interested enough to develop the technology.
Meanwhile, people have been thinking about this for 30 years.
Yeah, they have. So, indeed, there are clearly obstacles that are not just physical in nature. This is not just about trusting or believing in models. This is clearly about a much more complex societal problem. I agree with Kevin. Nobody has done it yet, but people are thinking about it, right? Fundamentally, you would need to go all the way up to the stratosphere to avoid these aerosols falling very fast. But currently, there is no other reason to go to the stratosphere, so nobody has developed the technology yet.
Okay, so everything you said, no one can act on right now.
No, they can't. Plus, the
So
moment...
why did I put you on the panel? Like,
I've been asking myself these questions since yesterday, but you know what? I'm here, so too late. But the fact that you could do something, hypothetically, is enough, indeed, because this is such a wicked problem, to cause countries to start thinking, what if another country does it? How would I be able to tell? Indeed, how would I be able to verify whether a country does it and says, no, it's all good. I'm not harming your citizens in any way. That is fundamentally really the largest problems.
Yeah, but of course, as Carl Sagan famously noted, air molecules do not carry passports. So whatever rule you put over the airspace of your country is not, that's kind of pointless given the overall circulation of air on our planet. But let me get back. I'm still moved by what Beth said about your absence of confidence in a treaty that the whole world can agree on once again. Holly, what does it take to get diverse societies to agree? You're a sociologist. Give me an answer to that.
Well, I wanted to push back.
Oh, I should ask, just to
actually.
clarify, as a sociologist, do you just study what people do and how they behave, or do you study ways to influence that behavior and what they do?
I study the stories they tell themselves about what they're doing. So, like with your Swedish colleague, actually, I found something quite different in my research when I was doing research in the northern part of Finland. People there were really concerned about what would happen in other parts of the globe because they're well educated. They understood that it would impact them through migration, through global economic impacts. And I think once people have that understanding of how entangled we all are, there's a shared basis for a discussion.
Interesting. And that's a level of enlightenment that not everyone carries, is what, not to put words in your mouth, but I think that's what you're saying.
In a way, they also have a much higher trust in government and just more social
They trust their
cohesion.
government?
More or less. But I think that it's an example that, we could do that. We could get there. And I also want to say that I think this field that Beth works in, it has a lot of insight, but I think people who approach it from an international relations standpoint, they tend to see the conflict everywhere. And I also think there's opportunities for peace building, for new forms of cooperation from this topic and this crisis.
Beth does not sound like that person.
I hope you're right. Honestly, I'm not looking forward to any kind of conflict on this. I just predict that there will be.
Yeah,
Because
and
you said, could they see how they're all entwined? But that's precisely what our system of sovereignty does not permit us to see. So states don't see themselves as entwined. I mean, look at some of our recent governmental decisions here. We don't see ourselves as entwined with anybody, even though in fact we are. So I like where you're going with this. I do. I just think it's going to take a long time to get there, and I don't know if we have that much time.
Dustin, what did we learn from the, COVID when for a while, no one was flying airplanes, we weren't going anywhere, so the atmosphere changed over that time. Are there lessons to be learned from that, good or bad?
Well, I can't speak directly to the atmosphere change part, but we did see disruptions in energy production. We saw disruptions in supply chains. Anybody have a problem getting something during that time, right? I think you've all experienced that. And from that experience, I think we realized that our energy systems and our economy was very vulnerable. We had built a system of just-in-time production to get things produced without much delay, delivery.
Which, by the way, is a major economic point of brilliance when you're not wasting inventory in a warehouse,
Exactly.
hoping someone buys it.
And then you
Right.
run out of toilet paper, and and everybody understands how important inventory actually is sometimes. So
Because of the toilet paper. Yeah, okay.
something that everybody can relate.
I have friends that still have a closet full of toilet paper, and it's a little scary, actually.
But I think the lessons learned are we need more resilient infrastructures, we need more resilient supply chains, and we need more resilient economies to go through challenges like that. And if we end up in a climate crisis situation, that could happen again.
So you're just saying that, or is anyone doing that now that we've learned from COVID?
Oh, I'm sure that everybody, I'm thinking like I study the battery life cycle and study battery manufacturers, and they're thinking about these things all the time because we saw not only with COVID, with the war in Ukraine, we see how important it is to have resilience in production systems.
What I find interesting is, I don't remember how I ended up on this list, but I'm on a list that receives ad solicitations for survivalist. Yeah, I think I bought something from a website at some point. And what's curious to me is a big selling item among the survivalists is a solar-powered generator. And I thought, that's kind of cool. We have survivalists using solar power. That's good.
Yeah.
It's a small.
It's very
gain.
small. It could be part of it, though. I mean, I think more. In California, we have a lot of blackouts because of wildfires sometimes, and that's another example of like having a system breakdown that's not that we all depend on, right? We all depend on, and lessons learned from that are decentralizing some of our energy systems, more smart grids. That helps make more redundancy in electricity delivery.
Didn't Canada threaten to shut off some of the Northeast power? How much of our power do they supply?
I'm not as familiar with the Northeast. Maybe Holly could speak to that one. But I know that you have to think of North America in general, both the pipeline systems that carry natural gas and the electricity grid as completely integrated. So,
okay, yeah, don't so fully integrate that we need a 51st state to
yeah. Tariffs aren't going to help.
Yeah, Howard, your plans to remove CO2. That's not the only greenhouse gas, as we know. Of course, there's methane, as which one of you referenced cow burps? Yes, okay.
He's the cow burp.
Yeah, how do you get methane out of the air relative to carbon dioxide?
Methane, the concentration of methane in the atmosphere is about 200 times less than CO2. So there's always people looking at, can we do this?
But I have a number in my head, but is it the number 16 or something? Times more potent a greenhouse gas than CO2
yes.
is.
So per molecule, methane is a more potent greenhouse gas, but its lifetime in the atmosphere is less. So they have this thing called global warming potential that compares the CO2 equivalent of these different greenhouse gases. So one thing that complicates this is if you use a 20-year greenhouse warming potential, the number is bigger for methane than, say, if you use 100 years. And so it's like talking about a discount rate in economics. Whichever one you use can have a big difference. I forget the exact number. What's it? 30, 2030, something like that.
With the number for what?
The greenhouse warming potential of methane.
It's 25 on 100 years, and I think it's 80 or 78, 80 on a 20
So
year.
the relative time. So methane would just combine with some other chemical. Is
Yeah,
what you're saying.
but
Oxid.
about 2/3 of the climate forcing comes from CO2.
Okay.
And I forget the exact methane's. I forget exactly 20% or something like that.
And what's the biggest methane source? It can't be only cows if we're also losing permafrost and we have organic matter
Yeah, so
thawing and then releasing.
So there's something with the climate science that people sort of use the word tipping points, that we go to a point that we start getting irreversible changes or dramatic changes, and one of it is if our permafrost melts, which has a lot of methane stored in it, will that start degassing methane? And there's no definitive answer on if or when that would happen and how bad it would be. The mechanisms aren't totally understood. But right now there's a debate whether the Arctic, the tundra, the permafrost up there is a carbon sink or a carbon source. It's always been a carbon sink, but it looks like it may start to become a carbon source now. And
Or greenhouse gas.
for greenhouse gases, and will that accelerate in the future, and will that become a tipping point?
Beth, what did you, in your writings, you talk about Arctic security. You just mentioned what was going on in the Arctic, the melting of the glaciers. What do you mean by Arctic security?
Well, the Arctic could be a fascinating bellwether for how we're going to adapt to a globally warmed world. Because the Arctic used to be just a big frozen lake with some water around the edges, surrounded by countries. But it's increasingly losing its ice cap, the sea levels are rising, and you're going to end up with sort of the new Mediterranean at the top of the planet.
By the way, I was very disturbed when I was 8 or 9 to learn that Santa Claus does not live on land.
No, he does not, but he will be speaking Russian soon.
Yeah, it's on his way, yeah.
Yeah.
He's on an ice floe, and it might not be there, and he might be in a bathing suit pretty soon.
He might be relocating someplace else, maybe to Canada, we don't know. But as the Arctic is thawing, you end up with new power relations between the Arctic countries. We have an organization called the Arctic Council, which assists with scientific cooperation and political negotiations and so on about the Arctic, but its charter explicitly excludes security. So if there's more icebreakers that we need, if there's more ice-capped submarines, if there's ocean transit going across the Arctic Ocean, through the Northern Sea Route or through the Northwest Passage, all this is going to have to be regulated in some way, because if it's not regulated, then possession is 9/10 of the law, and right now that points to Russia pretty much owning it.
Why not Canada? Canada has these land masses that go pretty far north.
Well, I'll defer to my geographer colleague here, but the basin basically is deeper on the Canadian side, which means there's more long-term ice there. The Russian side thaws first, is the gist of that. And so the Russians are already on this. They're building search and rescue stations, refueling stations. They're already charging boats tolls to break ice for them, to take their cargo across the Arctic Ocean. So the Russians are thinking global warming's working in our favor, which means that they're going to be operable up there in a way nobody else can be.
Isn't there a treaty that governs...
Governs what? The ocean?
The oceans?
Yes, there is. The UN Convention on the Law of the Sea came into force, I think, in 1982, and Russia signed it, and Canada has signed it, and most of the countries around the world signed it. Guess which country has not signed it?
Us.
Belgium.
That would be us. The United States has not signed it. We refuse.
How do you spell us?
U.S.
The U.S., okay.
USA number one? I don't know. But the reason we haven't signed it is because of sovereignty. The argument has been made in the Senate Foreign Relations Committee that this encroaches on our sovereignty. There's no need for us to sign it. We don't want anybody telling us what to do.
Holly, you authored a paper some years ago, which I just had no idea what it could mean. You talk about gender and geoengineering. Could you explain what was going on in that paper?
Yeah, so this came from a finding in my master's research a very long time ago, where I counted who was making statements about geoengineering in the press, and at that time, 97% of the assertions were made by men. And I was thinking, what does it mean for men to basically be telling the story of what this even is?
Because we want to control everything. That's obvious, right?
Well, I wondered, but I mean, we talked about a couple of different implications. One is who gets to represent it, who gets to say what it means, who gets to set the agenda. But then there's another question of, is the science we're doing adequately recognizing impacts on women, on, not just, you can extend this critique beyond gender.
So just people who don't have a seat at the table of who's making the decisions. It kind of comes down just to that, doesn't it?
Yeah, and so we made some recommendations about how we could maybe do the science differently.
Tell me about Africa. Most people don't know on a globe, I don't know whether it's because we're just deluded, but Africa can completely contain 5 continental United States.
3.5.
3.5?
Yeah.
What, do you have a degree in geography or something? What?
I show that map in my intro geography classes all the time.
Yeah, so how often is anyone talking about what African countries say about any of this?
African countries are certainly talking about it. And I, don't necessarily feel qualified to speak on their behalf. I can offer some observations. There's been...
You're not African?
No.
Yeah.
Yeah, and a lot of times we were discussing earlier, these conversations unfold about people who are not present or at the table, and we need to be very cognizant of that. But it's a very contested topic. I'm climate justice organizations from Africa that have taken a fairly strong stand against solar geoengineering. There have been those that have signed what's called a non-use agreement. There was a recent United Nations Environment meeting where a proposal was put forward and a block of, I'm going to get this wrong, but I think 15 African countries forcefully opposed the parameters of the proposal put forward by the Swiss that was backed by Saudi Arabia and the United States and some other countries.
So what reasons were given to vote against it?
That in that context, that it was lacking governance and perspectives outside the realm of science. So it was a very science-first approach that said we can let's do the research and figure out the ethical and political questions later, and there was pushback against that.
So Holly, that's a repeating phenomenon where you don't do the science first and then worry about the ethics later. You try to do it all at the same time. How realistic is that going forward for any new frontier of science?
I felt optimistic about it up until this point because we had...
Wait, up until right now? What did we do to you?
Up until,
No.
say, January, I don't know.
Okay.
Because that was the tenor of the conversation. We had this report from the U.S. National Academies that laid out a really integrated approach of doing governance, social science, all entwined.
On geoengineering. Right, that was like 2021, was that report? Yes. Okay. I browsed that report and it looked quite thorough to me. It's the National Academy of Sciences, so you should pay attention to it. And in there was a whole section on cautions and how to step softly in certain directions versus others where our uncertainties are. And that seemed to me okay. But Kevin, you published a paper criticizing that report.
Yes.
It had like 40 climate scientists as signatures on it.
Right. Okay.
So what do you know that they don't know?
My colleagues and I, we took issue with that report for a number of reasons. From, it was mostly physical scientists and economists, right? There was very little representation from humanities, social sciences, very little representation from civil society, grassroots climate justice organizations, the global south more broadly. But more than representation, which to me is secondary in this case, we felt it was a political intervention and not an objective scientific report. It was pushed by certain members within the geoengineering community, timed to kind of stoke this conversation within the Biden administration, which we saw happen. Members of Congress pushed the White House to put out a report that had very similar recommendations to the National Academy's reports, very similar budget laid out for what this research should entail, and we saw it as an attempt to, along with the intelligence community and a number of different foreign policy organizations that were coming out with very similarly framed reports at the same time, a push for U.S. leadership in this field over and above other countries.
Daniele, do you have a problem with the U.S. leading this? I know you want Italy to lead it.
I'll say,
that's
well,
fine.
yeah, I have a green card, kind of at risk. But anyway, but I'll be honest anyway, because I've decided to be. I don't care about U.S. leadership in this context or in any context. So in this sense, I fully agree with Kevin. I do not think that this should be a U.S.-only issue or even a U.S.-first issue. And part of my research, I collaborate with climate scientists and ecologists and earth system scientists from all over the world, especially Africa. I have to say I have multiple colleagues from many African countries that are as interested as I am to understand the potential impacts of something like solar geoengineering. And I think that's the only way. And yes, I do acknowledge, the differences sort of in their political power. But in a way, I don't care in the sense that that's not my part. My part is to do this from the bottom up with other scientists from all over the world. Is it going to work?
Which knows no national boundary.
Yeah, and I think that's still great, right? And so will it work? Will countries listen to us? Maybe not, but if we don't try, we'll never know. And it is great, to me, it is incredibly important to have that representation also at the level of other states and make sure that scientists from all over the world have the information they need to inform their countries about this issue.
You got one. You got an applause.
Yeah, there
Yeah,
you
okay,
go.
got
I know.
one. Oh, who hasn't gotten an applause
was-
yet? Will it work?
It was the green card that did it. They're like, they'll deport this guy in a month. Let's clap.
I want to. We're going to wrap up in a couple of minutes, and then we're going to open for Q&A from you. But I want to just bring something up which intrigued me, and I only recently learned about it just in the nick of time to be asked on national television this question. So let me just establish a couple of things. I don't know who of you has the expertise to bless it or not, but I'll just state it. So ordinary pollution that many of us old-timers in the room grew up with, smokestacks and this sort of thing, yeah, there's CO2 going into the air. There's also like soot that you breathe in. And I remembered, some of you might remember, you'd walk around in the morning and you have to brush off the ash that had landed on your shoulders from incinerators of apartment buildings that burned their garbage. Okay, that's what I remembered growing up. So you're inhaling this. This can cause respiratory problems. There's also sulfates coming out in this pollution. Those sulfates, over all those decades, have been persistently put into the atmosphere. Not high up, but it didn't have to be high up, because even if it fell out quickly, a fresh batch went up the next morning. And so, isn't it true that those sulfates, the kind you want to put up to block sunlight, was actually blocking sunlight for most of the 20th century in a way that delayed the effects of global warming, masking what was sort of brewing underneath, so that in fact we were an unwitting part of a geoengineering experiment. Mm-hmm. And so now that air is cleaner, the temperature rise is accelerating. So what do we do? What?
Right, yeah.
You just say, burn, baby, bring back the smokestacks? What do we do?
So, thank you for...
What's the number? How many people die each year of respiratory illnesses avoidable because of the pollution, traditional pollution? How many people?
Millions.
Millions?
Millions.
Tens of millions.
Tens of millions in the whole world.
In the whole world?
Yeah.
Okay.
So, I really want to underscore something Dustin said in his first intervention, which is, yes, cleaning up our air quality has immense benefits. Weaning ourselves off fossil fuels will have way more benefits just on the climate side. But most of them will be immediately felt by the people that will breathe cleaner air. And we should always be in favor of cleaner air. Defend the EPA with all you've got.
Yep.
And on this, the US has an incredible success story in this. Ronald Reagan realized how important it was to have good air quality and started cleaning up our air. And the US has been reducing the amount of pollution that they put up in terms of sulfate and soot by a great deal. And that's great. But on the other hand, there was a trade-off. And the trade-off was that we knew, and the IPCC knew already in the early 90s, that removing the Intergovernmental Panel for Climate Change.
Intergovernmental
Panel for Climate Change. They already knew in the early 90s that this removal of aerosol was going to unmask a small part of the warming produced by greenhouse gases. And yet, in this case, the trade-off was so obvious. Air quality kills so much more than climate change does for now, that it just made sense. Even acknowledging the complexity and acknowledging the trade-off and the risks, it just made sense from a fairness perspective, from an air quality, from many perspectives, to remove these pollution.
I don't know if I'm alone in this, but when I hear about people's respiratory problems, I don't often hear it associated with air pollution. Mm-hmm. And so this seems, to me at least, a hidden cause of death.
Totally.
A hidden,
totally.
The respiratory illness is not hidden, but the cause of it
Yeah.
is hidden. Right, and asthma and all the rest
Yeah.
of the breathing problems that we get.
And another thing that Dustin said, and an unfair one at that, as in not everybody breathes the same polluted air. And it's clearly black communities, poor communities, the communities that live closer to highways that breathe in most of that pollution, the pollution that is brought by all the stuff that we move around.
Dustin, what's that called when you...
Energy injustice.
Energy injustice. Tell us what that is.
Well, I think about it two different ways. One of them is what was just described, where some communities are overburdened with fossil fuel pollution or industrial pollution. But it also is...
These are like the lower rent section of town is near the power plant, for example.
Yep, I used to work in the chemical industry right down in Linden, New Jersey, where all those refineries were, and there's communities that live and breathe that air every day, and that would be an example of energy injustice, all this energy production, people being exposed. The other piece to that, though, is access to energy, and that's where we have a lot of people actually, I think more people die of indoor air pollution in developing countries than malaria every year.
Indoor air pollution.
Indoor air pollution.
What is that?
That's from cooking using fuels that are not modern fuels. So burning wood, burning dung, burning things like that indoors.
For cooking and
for
other...
cooking purposes or heating purposes. Yeah, and that's so energy inequity or energy injustice is both a question of access to modern energy resources as well as overburdened communities.
All right, it sounds like, I don't know that there's any solution here other than yours, but Beth, you don't have confidence in the international community to come to agreement on anything, and I agree with you on that. But, all right, Daniele has a solution. And so...
Is it a solution?
I guess not.
Solution, and I respect his scientific expertise on this. I'm not sure it's a solution, though. I think it's a stopgap measure that we're trying to apply in what we think is our scientific wisdom to the planet without...
Don't you want him to be available to you if nothing else works?
Yes, I do want him to be available to me. Hi. Yes,
Hey.
I'll call you later.
I really like you, Beth. You know that.
Available to me in this regard, but I think we need to rethink the framework that we're deploying these technologies in. Right now, every state is looking out for its own interests, and if they see that deploying these kinds of technologies, developing them, researching them...
When you say state, you
and
mean
so
country.
on. I mean a country,
Yes.
right. If they see this as their interest, they're going to pursue it, irrespective of any treaties or anything. And I think the way out of this, you think I'm doom and gloom. Here, I'll give you a trapdoor here. The way out of this, I think, is going to be...
That's a good trapdoor.
Yes. I think it's as a pillow underneath. I think that the way out of this is we have to rethink this idea of sovereignty, and I think we can do it. Even if it's selectively applied, we can think of a new security paradigm internationally that will allow us to respect the environment more.
And how does sovereignty extend above the troposphere? Is that possible?
It scientifically doesn't, no. But every country is going to think it does. They're going to make their own decisions based on their own airspace because for some reason they think they can control it. And you might say, yeah, U.S. Army, I'd like to see you stop that heat wave. They can't, but they're still making the decisions as though they can. So we have to tell a new story, if I can borrow Holly's parlance for a minute. We have to tell a new story about sovereignty and security. And that story is called ecological realism. That story is about how the environment, a healthy environment, sits at the basis of your security on this planet, because you cannot be divided ecologically from any other country. You can opt out of the trade regime. You can opt out of the human rights regime or the nuclear weapons regime. You cannot opt out of the environment.
We all occupy the same ecosystem.
Yes.
Is that a fair way to
Yes, that is absolutely true.
characterize that?
Yes.
Okay. Dustin, in a free country, which we tell ourselves we live in, we can argue forever about what should happen because it works scientifically, because you've got a model, because we can do that, but at the end of the day, don't we just do what's cheapest to do? And so the plan should really be economic, shouldn't it? If you want to change people's behavior in a free country, then short of beating them on the head, convincing them that way, just make this option cheaper than that option. Won't the whole system just flow without any concern for or any of these issues that are being raised?
I mean, that unfortunately, I think we do tend to take the cheapest option with a lot of these solutions that we bring forth. But going back to a point I made earlier, I think it's because we don't value a lot of the things that we degrade already. We don't value other species on this planet that we share. We don't value human communities. We don't.
That was
value
a cheap applause. In this museum, we have species everywhere on display. That was a cheap applause. You got that.
We don't value.
It was authentic, but it was an easy get. Right.
We don't value the equity dimensions that we just talked about. So there's a lot of other things that are, and I'm not advocating monetizing all of those things either, because I think that also opens up the door to, the tentacles of capital and problems that happen in a capitalist economy. So I don't think the path forward is the least cost solution. I think that leads to more problems. We end up, I see in my own work where the cheapest solar farms are promoted as a solution, and those are often the ones that have the biggest impact on wildlife and things like that, even technology that we all love. So
you want people to not just think economically, but come to some valuation of nature that factors into their economic decision.
To understand that there's other things than just monetary.
Howard, what you got?
So everything we do has a carbon footprint. How we got here tonight, what we ate for dinner, all carbon footprints. The way to do it is to send price signals, and then people adjust their things. And like 99% of the economists say the way to do it is to price carbon. And there's a lot of proposals out there. 20 years ago, there were actually some bills in Congress.
So this would be carbon credits.
A carbon tax or cap and trade. But politically, we have moved away from it. And this political climate we live in today, it's really a pipe dream thinking you're going to have a price on carbon anytime soon. So what we're left with is what the economists call second best solutions. Even those are getting hard to implement. And because we're not doing the things, I mean, it is so much cheaper to reduce our carbon emissions. My book on carbon removal coming out, the last sentence is, the best way to remove carbon from the atmosphere is not put it into the atmosphere in the first place. And we are having a hard time doing that. The Rio Convention was 33 years ago, 1992, where we said we're going to lower our emissions. We have more emissions today than we had then. So, that's why people are looking at things like the geoengineering. I look at it like a Hail Mary pass in football, where you really don't want to get to the point where you're forced to do a Hail Mary pass, because they don't always work. In fact, they usually don't work. Yet that's the road we're going down to. That's the reality of the situation. And I wish I had an easy answer, but I don't.
Holly, we're told that we need to reduce our carbon footprint. And so that you feel good when you do that, if you have the resources to accomplish that. But if we all reduced our carbon footprint, is that enough? Aren't there whole industries out there that have a way bigger carbon footprint than any one of us?
Yes, and I do think starting with industrial emissions makes sense in a way. But actually, the thing about the carbon footprint is there's that personal connection. And believe it or not, people in the US are interested in doing their part. They want to do something. They talk endlessly about recycling. They also feel like that was kind of a scam, and they feel disappointed because they were actually bought in, and they want somebody to tell them, like, here's the steps that you can take.
So you're referring to the fact that in the 1970s, we were all convinced that we were the bad ones by littering, and when we were being sold products that had a lot of stuff to discard once we consume the product. And so, but we thought it was our fault?
Well, I was thinking more about like the 90s when recycling was like the thing you could do, and people related to it on a personal level. They had specific behaviors that they were willing to engage in. Mm-hmm. And so I think that personal dimension is important, but I also think that there's big structural changes with how things are produced that are also important, and people get that. And
is that does that cross international boundaries? we're pretty wealthy here. Even the poor of us are wealthy relative to other countries. So what a luxury it is to say, I will, eat these foods that cost more than these other foods because it has a smaller carbon footprint. If I'm starving, I'm not making that decision.
Well, I don't want to start talking about international trade. That's a mess. But yeah, there may be things we could do in that realm too.
Maybe things we can do in that realm.
I just don't want to talk about tariffs, border adjustments,
Okay.
any of that tonight.
All right, so let's land this plane. So what I want to get from each one of you is your most hopeful vision. And I'll skip Beth because I don't know that she has a hopeful vision here. What's Kevin? Professionally, you've been quite grumpy. You've been very polite tonight, but professionally, your published works are quite grumpy.
True.
So give me something to look forward to.
I'm told there might be wine after this event.
Okay.
Can I?
Oh, sorry.
Sorry,
Okay,
no,
go on.
can
That was not your answer?
That
Okay,
was
go.
not. And I really don't know if I want to answer that question. I want to just, before we leave the room, I would be remiss to not, because of the last two comments, the one reason we're talking about solar geoengineering is because it's so cheap, right? It is, in my opinion, a potential get-out-of-jail-free card for all of the very difficult things that we have to do that will actually make the world a better place. And it might not be just a stopgap measure because it is so cheap. It might have to continue for centuries, right? And it would potentially get, the more stuff we have to put in the stratosphere, the worse the side effects get. So I think before we head down
it's
that
not
road,
a solution, it's a Band-Aid.
if that, yeah. So I think we need to, if we're at a point where we do need an extreme Hail Mary intervention like solar geoengineering, my preference would be to think more about extreme interventions into the economic system that is driving this.
Okay. It's like the third time we've heard the term Hail Mary. For those who are not football fans, the very last play of the game, if the team that has the ball is either tied or behind, and they just have to score a touchdown, and then they'll win the game. So they start the play, the time runs to 0, so they have to make this play. And they're not going to trust running with the ball because you could get tackled. So the quarterback takes the ball and throws it high into the air so it just lands in the end zone. And everybody's huddled around trying to catch the ball as it arrives. And you're hoping one of your players catches the ball. And if he does, it is a successful Hail Mary pass. Otherwise, I don't know that we have a word for it. But you're putting it all on that last throw. And just in case people needed to be updated on football reference. Holly, give me something to look forward to.
So I've been around the country for the past 2 years talking to people, including a lot of Trump voters. And people, obviously, they're really fed up with the status quo. They're fed up with big corporations taking advantage of them and their communities. And I think that there's actually a huge opportunity here that some political parties have failed to take advantage of that could shift things in the right direction if we found leadership that could talk to lots of different audiences. I actually feel, despite this being like maybe the darkest moment, there's a lot of potential for political change in this country that can move things on energy.
Beth, that's how to be hopeful.
Okay.
Okay, can you take a cue from that? What do you have for me?
Yes, I can. I do think that if enough countries get together to form some kind of anticipatory governance structure, we can maybe get some of the big powers to sign on to it. I think if we govern...
Wasn't that the UN? Isn't that what the League of Nations, the UN? What are you talking
The UN would be
about?
the basis for it, right? But if we govern geoengineering like arms control, then we might be able to get enough states to sign on to say, okay, we think that if, as long as everybody else agrees, we'll agree too, and we might make some progress that way.
Okay, so it's a geopolitical solution to moving forward.
Yes,
Yeah,
it is.
okay.
But I don't know if it's the solution we all need, it's a solution we can have in the moment.
Gotcha. All right. Dustin, give me your best solution going forward.
Well, I'll bring you an example from California, where I spent most of my life, first half of my life here in New Jersey, and lived the second half there in California.
And you came to this museum as a kid.
And I came to this museum as
Yeah,
a kid,
cool.
in the school bus. I recognize all the halls. Came to the planetarium when it first opened.
No, you saw Laser Floyd.
Oh, I saw
Honest.
Laser Floyd at the
Yes.
old planetarium.
Yes.
Yep. But we've had, several months worth of the year where we're running on 100% renewable energy. We have batteries now powering, carrying almost 40% of the load in the evening when the sun goes down. And those are filled with the sun during the daytime. So, and we're still 20 years away from what our 100% goal is in the state. So we're rapidly evolving a renewable energy system that's displacing carbon emissions, and that's really the name of the game, to stop
And that's
burning.
happening slow and steady, so that you're not noticing a difference one day to the next. But maybe we'll wake up one day and the carbon footprint has been shrunk.
At least on the electricity supply.
To
say
insignificance.
Keep the point of the fertilizers and the points about the animal agriculture are still out there, need to be addressed. But rice production in California, we've done substantial reductions in methane emissions from rice production, which is another source from agriculture.
Because rice germinates anaerobically, and so oxygen is not part of it, so one of the byproducts is methane. So CH4 without oxygen.
This is the best host you got here. This is great.
So Howard, help us out here. What's your vision of the future?
So there's a lot of technology out there that can really help us reduce our carbon emissions. And there's actually more there's more technology out there that we can get implemented, whether it's renewables, whether it's nuclear, whether it's electric vehicles. The problem is the incumbents, fossil fuels, are so cheap. So these technologies...
Cheap and portable.
What?
Yeah, you dig it out of the ground and move it to another place.
And plus technology has also improved the production and use of fossil. So in order to get these new technologies to really get deployed and do it, you need policy. And, the example of California, that didn't happen organically. California put in a lot of policies to do that. That's what we need for the rest of the country. That's what we need for the rest of the world. So technology alone cannot do it.
Enlightened management of utilities in this way.
Say it again?
Enlightened management of utilities.
Yeah. It's not just utilities. It's, because utilities own about 30% of the energy we use. So it's everything in the economy, but there's technologies for everything in the economy if we put the policies in place that move us towards that. Now, if we did this 20 years ago, you can slowly put it in. The more we wait, the harder it is because we need to do it faster.
Daniele Bittione, take us out.
Well, I want to say that sometimes even if you have no hope at all, you still got to do what you think is right. And this could be really one of the cases. I don't think we should think about this in terms of hope, but as much in terms of, this is our responsibility. This planet is our responsibility. Have we messed up? Yes, but we've messed up in the past, and this shouldn't let us stop from thinking about what can we do next. And in a way, yes, something like solar geoengineering is scary, and of course it is, and it should be. I hope it stays scary. But on the other hand, it could be part of what gets us out of all of this. Especially if we acknowledge that that's not the only thing, especially if we acknowledge the larger problem, especially if we acknowledge our responsibility for this planet, that's the part in which solar geoengineering could play a part and allow us to move past and actually become the real steward of this planet.
Thank you, panel.